Okay, just the last thing I want to cover for these equation solvings is what's going to happen when we've got a little bit extra going inside of the cos function. So all the ones before that we were solving, the inside was just theta, and now specifically we have this 3 times theta. And so that's going to make things a little bit more interesting for us. So we just have to be mindful of that. As always, we'll start by isolating the trig part, the cos 3 theta. So we should be able to solve that and realize what we're going to get is cos 3 theta is -1/2. So that's a negative cosine, so we can use CAS to figure out where 3 theta is going to go. So it's going to go on the left side since it's negative. Draw our circles here. And sorry, draw our triangles. They're sort of on a circle, but draw our triangles. And we have -1/2, -1/2. We can solve for the third sides, which should be √3s. And that is going to be our 30-60 triangle. So our reference angle is opposite of the √3. So our reference angle is 60 degrees. I was going to try to squeeze that in there, but it didn't work. Okay, so now this reference angle, this is for 3 theta, not theta. So we're going to first solve for 3 theta. And so if we do that, we'd get the 2 angles from this picture. So we'd have this one and the second one that goes down a little bit further. So we should have 180 minus 60 and 180 plus 60. So that's 120 degrees and 240 degrees. And I will convert both of those to radians. So we've got, this is 3 theta is 2 pi over 3. And this one would be 3 theta is 4 pi over 3. And so what that tells us, we can just solve for theta now, and we get theta is 2 pi over 9. And so theta is 4 pi over 9. Now, there's a bit of a problem here in that there are more answers. So we're not actually done. So if we were to investigate the graph of cos 3 theta, so if you remember what that's going to do, it's going to squish our period down. So our period is going to be 2 pi over 3. And so if I actually am doing an entire graph from 0 to 2 pi, there's going to be 3 periods in this graph. So it's going to go down, then up, down, then up, down, then up. So there's 3 full periods, which means that our answers of -1/2, which are occurring around here and here. So this is our, let's call them theta 1 and theta 2. Let's go right here. So in that picture, there's going to be a whole bunch more. In fact, we need 2 more sets of answers. So what we've actually got here is for every additional period inside of 0 to 2 pi, there's going to be more answers. So we have to add a period. And then the same thing up on the top to get to the corresponding answers over here. So basically what we need is for every answer, we actually need to have 3 answers for the fact that there's 3 periods in the solution. So this should actually be a set of 3. And so what we need to do is add the periods. So what we could do here is actually add 3 theta equals 2 pi over 2 or, 2 pi over 3 plus 2 pi, or 2 pi over 3 plus 4 pi, right? Because those are just going to be additional circles in this picture. Or we could even add another circle. It ends up in the same place. But then what it's going to do for our answers over here is generate more solutions. So for every one answer that we get in the circle, we actually need the number of periods, which is this number here. There's 3 periods in that circle. We need 3 answers to go with it. So what we're going to get is, so this one, if I work that out, it should be 8 pi over 3. And then this one should be 14 pi over 3. And so those 2 answers are going to become 8 pi over 9 and 14 pi over 9. And then same thing with the 4 pi over 9. We need to get the 2 more. So we have to add a 2 pi over 3, which is the same as 6 pi over 9. So 10 pi over 9 and 16 pi over 9. So there's actually 6 solutions in there. All of those answers, if you look at them, they are between 0 and 2 pi. So they are, in fact, in this set that we're looking for. It's just we have to know to make more solutions. So we'll do one more of these, but I'm going to lose the big explanation and just kind of go through procedure. Okay, so this one, we've got a polynomial of cosine. So if I were to do a substitution, I'd have a y squared minus 4y minus 5 is 0. That one should be factorable. Y minus 5, y plus 1 equals 0. So you can switch it over anytime you like. I might write this as cos theta minus 5 times cos theta plus 1 equals 0. And so this says cos theta is 5. We can reject that because it's outside of the range of cosine. But cos theta equals -1 is okay. So that's on the plus or minus 1. I won't use a triangle to solve it. What I'm going to do is use my graph of cosine. And maybe I'll use theta instead of x because that's what I'm solving for. Oh, wait a minute. I'm missing my numbers here. What I wanted was a bunch of 4s. So I'm going to sneak those in right now. 4 theta, 4 theta. There we go. Otherwise, it's just a question from before. So yeah, it didn't really matter to get it started because the starting is really just the exact same as starting the other equations. It just gets interesting after, and I realized that it didn't look very interesting. So I'm just going to make it more like what we're trying to learn about right now. Sorry about that. Okay, so yeah, I am actually going to look at y equals cos x specifically. And we know that that graph looks like this between 0 and 2 pi. And so my -1 is down at the bottom there, which occurs at x equals pi. So in this case, the x is actually going to be my 4 theta in that picture to the right. So for my solution in 0 to 2 pi for 4 theta is 4 theta is pi. So what we need to do now is actually expand it. So because I have 4 theta out front, what I'm going to need to do though is add 3 more periods. So add 3 more 2 pi periods to get a total of 4 solutions. So what I'll have is 4 theta is pi, 3 pi, 5 pi, and 7 pi. So those are all my answers in 0 to 2 pi for 4 theta. So now what I'm going to get is my answers in theta. We just divide the whole thing by 4, everything. So what I'll get is theta is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And all of those answers are still between 0 and 2 pi. Right, 7 pi over 4 was less than 8 pi over 4, which is exactly 2 pi. If we added another answer, we'd have 9 pi over 4, which is outside of the region that we want. So we want exactly 4 answers corresponding to every solution that you find. So basically, when you solve for the 4 pi thing, what you're going to do is have 4 solutions for every solution in the circle that you can find.